The idea of converse theorems. So basically, converse theorems is using the geometrical theorems but in reverse. Let me show you what I mean. If you had 3 points and they form a right angled triangle, so there's no actual circle there, but because we know the angle in the semicircle theorem, we know this. The circle whose diameter ends up being the hypotenuse of a right angled triangle, then it must pass through the vertex of the third vertex of the triangle. Let's draw a picture. It's probably easier to explain with a picture. So if I just had a right angled triangle, I know it's possible to draw a circle through all 3 points. And AB would end up being the diameter, and then C would be the angle at circumference, and we could say angle in the semicircle. Now sometimes that's useful because we're trying to solve a geometry problem, and we notice something like that. Then we know, oh, hang on, we can draw a circle around that. And then that might open up a whole heap of other theorems we could use, other circle geometry theorems that we may not have seen initially. So if I was going to use this idea in reverse, I'd say, well, look, I know A, B and C are concyclic, and AB would be the diameter. And the reason being, well, the reason I'm using is that same theorem, but I'm just using it in reverse. Angles in a semicircle are 90 degrees. So I could do a similar thing with something like this. If I had 4 points, but I notice from AB, then the angles are the same. So AQB and APB end up being the same. Then again, it must be possible to draw a circle through all 4 points, because the situation we've got there is angles in the same segment are equal. So I could say APQB is in fact a cyclic quadrilateral, because all 4 points would lie on the circle. And the reason I can use that is I'm using the angles in the same segment theorem, but I'm using it in reverse or converse. Or simply if I've got a quadrilateral and I notice the opposite angles add up to 180 degrees. Same again, I know that's a cyclic quadrilateral. So I see, we've got some sort of diagram. Oh, look, opposite angles, they add up to 180. Then I can say, yes, well, look, A, B, C, and D definitely are concyclic. Or I could say A, B, C, D is a cyclic quadrilateral, either way. And the reason, because we know opposite angles in the cyclic quad are 180. Okay, so that was a very quick one to start off with there today.